Hey guys, it's me. It's just math, y'all. Welcome back. We're going to be starting chapter 5. This is Math 100. We're starting chapter 5, and we are going to be doing factoring. So, there are 4 types of factoring we're going to learn in chapter 5, and so please keep this in mind that we will go through and learn each type, building on top of one another. And so the first type is GCF. The second one is grouping, and those are in section 5-1 in our book. And then we will use the others. And when it comes to factoring, you can always check your answers by multiplying. So today we're going to do GCF factoring. Okay, here we go. All right. So type 1 is GCF. Basically, this is the reverse of the distributive property. Okay, and so when we did the distributive property, we did multiply. We did the 3x times the 4, and we got the 12x to the second. And we did 3x times the 9, and we got 27x. And so the idea is that now we are reversing it. We are reversing it. Now we have 12x to the second plus 27x, and we want to rewrite this as a multiplication because that's what factor means. Factor means to rewrite as a multiplication problem. And so the first thing we want to do is see if there is a common number that maybe multiplied everything, that everything is divisible by, or that we could divide everything by. And it's that same idea. Greatest common factor is the same idea as reducing a fraction. So if we look at the 12 and the 27, we can say to ourselves, what number goes into both the 12 and the 27? If that was a fraction and you had to reduce it, you would go through your mind and say, I think 3 goes into both of them. Well, 3 is the greatest common factor of 12 and 27. Now, for the variables, it's very easy. All right, so for the variables, you take the least power or the smallest exponent on each common variable. And so for this problem, they both have x's. They both have x's, and so x to the first is the smallest one, and so that's the GCF, or the common factor of that variable. So 3 is common for the numbers. X to the first is common for the variables. Well, then we basically divide. Or we say 3 times what? So 12 divided by 3 is 4. Or you could say 3 times 4 is 12. And then x squared, and we remove an x. Remember, we subtract the exponents, would leave an x. And then we do the next one. 27 divided by 3 is 9. And then x divided by x is 1. And so that's what we have done. We have factored out the GCF. So let's look at the next one. The common number, again, if this was a fraction, you would reduce by 7 because both numbers have a 7 in common, so that's your common number. Your variable, you take the smallest power. They both have x's, and so the smallest is x to the third. And so this is our GCF right there. And then we open up a set of parentheses because we're going to rewrite as a multiplication problem. So we divide. 7 divided by 7 is 1. X to the fourth divided by x to the third would just leave me an x. Be a minus 7, a negative 7, so it'll be another 1, and that would be it. So that would be the GCF, factored it out. Now I can check both of these through multiplying. You can always check your answers through multiplying. And so if you think about it, if I did 3x times 4x plus 9, 12x to the second plus 27x, and that checks. And for the other one, if I do 7x to the third times 1x minus 1, I'm going to get 7x to the fourth minus 7x to the third. And that checks. So this is the idea behind GCF, factoring out of GCF. All right. So now my next video is going to be a bunch more examples. So come back and see the next video with a bunch more examples.